The Cool Copper Collider, C3, represents a shift towards sustainable particle physics, with a design that could halve energy consumption and a construction process aimed at reducing the carbon footprint of collider projects. Ever since the discovery of the Higgs boson in 2012, physicists have wanted to build new particle colliders to better understand the properties of that elusive particle and probe elementary particle physics at ever higher energy scales. Researchers from the Department of Energy's SLAC National Accelerator Laboratory and Stanford University have thought through how to make one proposal, the Cool Copper Collider, C3, more energy efficient. C3 aims to solve the length versus energy limitations of most linear accelerators with a new design, including more precisely tailored electromagnetic fields fed into the accelerator at more points as well as a new cryogenic cooling system. The project also aims to use more interchangeable parts and a construction approach that could significantly lower costs. Historically, physicists did not pay much attention to how they operated accelerators, at least in terms of energy efficiency. The SLAC and Stanford team found, however, that subtle changes, such as changing the structure of the particle beam and making improvements in the operation of clystrons, could make a difference. Construction itself is likely to be responsible for the bulk of the carbon footprint for C3, especially as the world shifts to using more renewable energy. The researchers suggest that using different materials, such as different forms of concrete, as well as attending to how materials are manufactured and transported, could help lower the global warming impact. The researchers also considered where the C3 project would be located, since that could affect the mix of fossil fuel versus renewable energy that powered the collider, or potentially building a dedicated solar farm that would, along with an energy storage system, cover the accelerator's needs. Based on their analysis and similar sustainability studies for other accelerators, the team found that construction is likely to be the main driver of a project's carbon footprint, but that circular colliders capable of similar physics goals would generally have higher emissions related to construction. Likewise, shorter accelerators such as C3 and another proposal, the Compact Linear Collider, would have less global warming potential compared to longer ones.